Hello everyone, in today's video we are going to see the live demonstration of our diploma final year project titled as Melanoma Detection using Deep Learning. To start with, I'll explain what is melanoma. So melanoma is a very serious type of skin disease which develops in the cells that produce melanin and forms tumor. Tumor can grow and can spread to the other parts of the body as it is malignant. Many a times it gets developed from a normal mole a person already has on their skin. In recent years, melanoma has been widely spread in India, especially the northern India and the northern eastern states of India, as per the data provided by the Indian Institute of Medical Science. Thus, access to highly reliable systems that can detect the presence of melanoma via skin mirror image of lesion can be a very helpful tool in medical diagnosis. Next is why and how deep learning can solve this. Because there are many machine learning algorithms and framework, you'll say, then why deep learning? So the purpose of opting for deep learning is that it allows the developer to build multi-level structures which are very helpful in extracting detailed information from the input image. When talking about deep learning and image classification, it's quite obvious that we have used CNN, that is convolutional neural network, which are able to reduce computation time, gives high percentage of accuracy, and keep low data loss during model training. Thus, using convolutional neural network when developing a image classification model is very effective, and that is the reason we have used convolutional neural network for our project. So now coming to the melanoma model, first comes the organization of files. The first folder here is melanoma, which is the primary data set. As the data is segregated into four categories, it is already predefined and is ready for the supervised learning. The data set used is provided by the Indian Institute of Medical Science, so it is a verified data. Next we have is static. The function of the static folder will be explained later in this video, but for now, here the image file will get saved, which will be uploaded by the user as input. Next, we have the template folder, which contain the front end design view part. Next is test. Test folder is the folder which contains the images which are going to be tested on the model. And then we have app, which is the Flash based web application, CNN, which is a CNN structure, model file, the training file, and the predict function file. So this is the front-end design created using Flask, HTML, and CSS. Here the user will give input as their name, email, age, and will choose and upload the lesion sample image of their infected part. So before showing the working of this model, let's understand how this model is created. This is the model training file named as multiclass CNN. Part 1 here is building the CNN, that is convolutional neural network. First, we have imported all the necessary libraries starting from sequential, which allows only one input and one output tensor. Next is convolutional 2D, which creates a kernel that allows the model to produce multiple tensor of outputs. Next is max pooling 2D, which calculates the maximum value for patches followed by flattened, dense model from JSON matplotlib. Then there is batch size as 32. Why 32? Because it is the number of training examples used in the estimation of the error gradient hyperparameter for learning algorithm. So what this will do is it will create the dataset into batches. In 32 batches, the number will be decided by the model as per the number of images available in the dataset, and the features will be selected on the basis of the batch size available. In this part, we have added the directory from where the dataset will be fetched. As you can see, here are the classes mentioned, and these are the folder names in the dataset. Target size we have kept 200 because all the images will be resized to this format and there will be no differentiation in the size of the image. After getting 128 neurons here, next comes the softmax activation layer. What is softmax activation, you must be thinking. So softmax softmax activation layer is the layer which gives the final output layer that allows multi-class recognition, which actually means is that this layer is going to give the output layer which will give the final recognition identity of the model. So here the total four classes are made, and if we look at the classes which we have created, there are total four classes which we have created. So a model is exactly right. So part 3 is the model summary. We have used model.summary to look after what all parameters are there, how many layers are there. So while executing and training the model, this will give the model summary. We have used pyplot to get the accuracy graph and the data loss graph once the training is completed. Now let's run this model and train it. To train, I'll click on run and I'll click run module. This is the Python shell. We are using Python idle because we are not having GPU as it is not a workstation. As you can see, uh, the, as you can see, TensorFlow environment is already activated and soon the training will get started. So this is the model summary as you can see, and now the training is going to start. Training the model takes a lot of time and it is a very time consuming task. So we have increased the speed of this video for this phase so that it can complete all the epochs in a short duration of time. So part 3 is the model summary. We have used model.summary to look after what all parameters are there, how many layers are there. So while executing and training the model, this will give the model summary. We have used pyplot to get the accuracy graph and the data loss graph once the training is completed. Now let's run this model and train it. To train, I'll click on run and I'll click run module. This is the Python shell. We are using Python idle because we are not having GPU as it is not a workstation. As you can see, as you can see, TensorFlow environment is already activated and soon the training will get started. So this is the model summary as you can see, and now the training is going to start. Training the model takes a lot of time and it is a very time consuming task. So we have increased the speed of this video for this phase so that it can complete all the epochs in a short duration of time. So now our model is trained and is stored in the Melanoma Detector folder. Now we can execute this model and check whether it is working or not. To your view, I would like to inform that the predict function is already connected to the Flask, that is this web application, and now we can go for the execution part. Let's take any random name and let's choose this file. Okay, so this is the test folder and these are test images. So let's take this example and click on submit. Okay, so we have something wrong here. Now, yeah, it's done. So as you can see, we have received the result as 80%. So when we go and check the folder static, so in static, you can see that the image is saved. As I mentioned in the first part that the image which will be uploaded by the user will get saved in the static folder. So now it's 100% working. So we can conclude that our model is fully working and is operational. Last but not the least, I would like to thank our college Vidyalanka Polytechnic for giving us this opportunity, Professor Prerna Jangaonkar for helping us throughout the completion of the project, and my classmates for their constant support throughout the journey. Thank you everyone.